Always use caution when working on power supplies of any kind. Capacitors can store power for a very long time after the power supply is unplugged. No normal human being should attempt anything shown in this video.
Originally, this power supply, when I first got it, was putting out 5.1 volts. Every time I've measured voltage coming out of a voltage regulator, it's usually dead on 5 volts. And I thought, well, maybe that's a sign the voltage regulator is starting to fail, or it's built to a poor tolerance. But as you'll see, when I change the voltage regulator, I don't quite get the result that I was expecting. All right, I think what I'm going to try doing is to remove the epoxy in this area to see if we can get to the regulator, or possibly get an idea where the circuit board itself is, the one that has that 4700 microfarad capacitor. Because I'd like to at least check it if I can, if not, replace it. All right, so I made some progress using this chisel and this mallet, and carefully tapping in places, I was able to break the epoxy off in quite large chunks. I don't know what I'm going to do with it. Commodore must have gone through many drums and vats of epoxy with the amount of epoxy that's in here and the amount of power supplies that must have been turned out. And I want to point this out. We are on the output side. This is the bottom. This is the output side that goes to the Commodore 64 of the power supply. The PCB on this type of power supply is on the bottom. It's just below the epoxy right here. And this screw here is what's holding on the 5-volt regulator. I've had some success exposing the PCB here. What I've been doing is taking this chisel and aiming it upwards and trying to hit only the epoxy. And if you tap it, sometimes you can get the epoxy to break loose in big chunks. It has not adhered very well to this circuit board here, this PCB. So that is an advantage, but I will warn you, when this stuff goes, when you break a piece loose, it cracks and it can go flying, and it's really sharp. So you definitely want to wear some kind of face mask or face shield, something that covers your eyes, safety goggles, that sort of thing. And right here, these 3 leads here that are soldered in, that's the 5-volt regulator right there. It turns out the heatsink that the 5-volt regulator is attached to, it's this aluminum piece of metal that goes all the way to the other end. All right, the way to remove this is you chip off all the epoxy on the outside of it, and then you get in between here and the sides, and you, like you do with originally removing the plastic case, you just break whatever adhesion there is between the epoxy and the metal shield. I think this thing might also double as an RF shield. I had desoldered the 5-volt regulator thinking that it would likely pull out with the epoxy, but that didn't happen, and well, I mean, it wasn't really working that great anyway. But half the regulator stayed there, and the other half went with the heat shield / RF shield. There's the voltage regulator accidentally split in half while trying to remove it. So this brown wire and this blue wire I accidentally severed while I was tapping with the hammer and chisel to try and knock off some of these pieces. In this case, I went a little too far, and it's easy to do that, and I have to repair these two now. I got the wires soldered back together. There wasn't much wire to work with, and it was hard to, was difficult to get heat shrink tubing on them, and I added some electrical tape to this just to make sure it was good and insulated. Got the voltage regulator, or what was left of it, removed. You can see that I ground out around it a little bit with the Dremel tool and the cutting bit, and then I just kind of pried it out with the small chisel I've been using. I installed the new regulator. I measured the output. It's almost exactly 5 volts. It's 5.01 or something like that. And when the regulator wasn't installed, I did plug this in and measure the voltage across these two, across the two, where the two leads on the ends are, and I got about 14.5 volts DC. So that, I guess if this completely shorts out, you'd probably be putting that into your computer. And very important, I did plug this in when the regulator was removed, and I measured the voltage, and after I unplugged it, it stayed at 14.5 volts for quite some time. When you're dealing with things like power supplies that have big capacitors in them, just because you unplug it doesn't mean that there isn't still electricity present. And in this case, I think there's probably a big capacitor in here that was charged up. I ended up discharging it by putting carefully putting a resistor across the 2 points. And here is where things get kind of strange. I measured the voltage output here. It is exactly 5 volts, as I said. However, when I measure it here at the output that plugs into the computer, I get 5.13 or 5.14. So somehow there's a tenth of a volt finding its way into the 5 volt line. I did try moving the wires around and moving the meter around to make sure it wasn't some kind of electromagnetic interference, but it does appear that there's a tenth of a volt leaking in here, which makes me suspicious of this thing even now that the regulator is replaced. If I don't know where that's coming from, there's no way to say that it won't get worse. This still puts out the 10.9 volts on the 9 volt AC line, so that seems to be working. There's no way to guarantee that that tenth of a volt extra won't increase to 1 volt or 2 volts or something and start damaging chips in the computer. There's no way to verify that without actually knowing where it's coming from, and given the amount of epoxy still present on this thing, I'm not sure I'm going to be able to determine that. So for the time being, I think I'm going to shelve this project. And here's the pieces of epoxy that I removed. They come off, they're fairly brittle. I don't know if it was that brittle when it was poured in and cured, or if it became brittle over time. I don't suppose that elasticity was so important for the epoxy potting in this power supply. Not sure what I'm going to do with these pieces. I mean, maybe I could wrap this up and give it to someone as like a 3D puzzle. They probably wouldn't appreciate that. It smells pretty bad and the pieces are sharp.